Welcome to our project SmartLender, Applicant Credibility Prediction for Loan Approval. This project has been developed under the course Machine Learning in partnership with Google offered by SmartBridge. SmartLender is a machine learning-based web application that predicts whether a loan application is likely to be approved or rejected based on user-inputted financial and demographic details. It combines machine learning with a sleek user interface to provide real-time, reliable insights for applicants and lenders alike. Let's take an insight into the data set. We used a public data set from Kaggle containing information like applicant gender, marital status, education, employment status, applicant income, credit history, loan amount, and property area. To understand the data better, we performed exploratory data analysis. First, we analyzed distributions of key features like income and credit history using univariate plots. This helped identify skewed data and potential outliers. Next, we explored relationships between categorical features like marital status, gender, and loan approval using bivariate analysis. We also found that most applicants were male and graduates. Moving to multivariate analysis, we studied interactions between features, such as gender, income levels, and loan approval. Further, we compare male and female applicants' income levels and their loan approval likelihood. Patterns like income disparity or high variance can be spotted. Lastly, we reviewed descriptive statistics and checked for missing values to guide the pre-processing phase. In the pre-processing step, we handled missing values and encoded categorical variables using label encoder and one-hot encoding. The data was then scaled using standard scaler to bring features to the same range. We also address class imbalance by applying SMOT-TOMEC, which balances the data by combining oversampling and undersampling. These pre-processing steps helped ensure the model learned effectively from the input data. We trained and tuned 4 different models using randomized search CV. These included decision tree, random forest, k-nearest neighbors, and gradient boosting classifier. For evaluation, we used accuracy, F1 score, confusion matrix, and cross-validation scores. Each model was tested and compared to find the most suitable one for predicting loan approval outcome. Among all models, the Random Forest Classifier gave the highest F1 score and balanced accuracy, so we selected it as our final model. We then saved the model and the scaler using Pickle, making it ready for integration into our Flask web application. We built the front end using HTML and CSS. The homepage introduces the project and invites users to begin their loan prediction journey. The layout is clean, user-friendly, and mobile responsive. On the form page, users enter their personal and financial details, including income, employment, and credit history. The form also includes drop-downs for categorical fields and validations using JavaScript to ensure clean inputs. This form is connected to the Flask backend for real-time prediction. After the form is submitted, the Flask backend loads the trained model and the scaler, then scales the input and generates a prediction. Based on the result, the user sees a clean output page with either approved or rejected status. The prediction is made instantly, ensuring a smooth user experience. The project has been fully documented and uploaded to GitHub. It includes code files, model files, the trained scaler, and a requirements file for easy setup. We also created a proc file and deployed the web application using Render for free hosting. The GitHub Repository link and deployed app link are both provided in the documentation. SmartLender demonstrates how machine learning and web development can be combined to solve real-world problems. The project has been led by Yash Chugani. Special thanks to team members Ashish Kumar, Mandyani, and Yash Darad. To explore the code, models, and try the application live, visit our GitHub repository and the deployed website linked below. Thank you for watching.